Assalamualaikum and a very good day. My name is Sri Amisha binti Muhammad Hashlin Darinsha, metric number AP200385. Today, I would like to explain about electron beam melting, EBM, 3D printing. Electron beam melting is a 3D printing technology that uses an electron beam to fuse metal powder together to build parts. I will explain how this technology works, point out its pros and cons, and showcase where it's utilized. Electron beam melting (EBM) is a 3D printing technology that at first glance appears very similar to SLS 3D printing. However, closer inspection reveals that EBM differs in several ways. The most significant difference are that the energy source comes from an electron beam instead of a oxygen laser, and that the material used is conductive metal instead of thermoplastic polymer. In particular, EBM often use titanium alloy and is not capable of printing plastic or ceramic parts. That due to the fact that the technology is based on electrical charges. They are what produce the reaction between powder and electron beam, causing the former to solidify. All EBM 3D printers consist of an energy source capable of emitting the electron beam, a powder container, a powder feeder, a powder recoater, and a heat build platform. Important to note is that the printing process must take place in a vacuum. That's because electron of the electron beam would otherwise collide with gas molecule, which would kill the electron beam. Next is printing process. First, for pre-printing, before the printing process can begin, the powder bin is filled with the desired metal powder. Once that's done, the powder bin is placed into the 3D printer and the internal pressure is set to around 0.001 mbar. Believe it or not, that's around 10 million times less than atmospheric pressure. When the desired pressure is achieved in the build chamber, the electron beam is fired up, heating the build platform to high temperatures. For example, titanium requires 600 to 700 degrees Celsius. After the build platform is heated, the printing process can be finally started. Next is main event. The 3D printing itself starts with the powder recoater, which deposits a single layer of preheat powder onto the build platform. Once the powder is set, it's time for the electron beam melting to begin. The electron beam is controlled by a set of electromagnetic coils, which accurately point the beam towards the desired points of the build platform. The electron beam moves selectively while melting the powder and causing the powder particles to fuse together. After one layer is complete, the build platform is moved down one layer in height. The recoater comes in again with a fresh layer of powder, and the electron beam starts to induce fusion of powder particles, causing the new layer to form. This process is repeated until the entire part is finished. For the post-processing distortion, the EBM 3D printing process involves high temperatures, which can be a problem for parts. If they are too hot for too long a time, they can distort. This is the main reason EBM requires supports, whose main function is to provide part for excess heat to go away, and not to provide mechanical stability like SLS. The latter is provided by the semi-sintered powder that surround parts. For the final step, when parts are finally finished, the powder bin is taken out of the 3D printer. Despite the parts already being manufactured, you still can't use them yet. For starters, they have to be left to cool. Despite the supports being made from the same material as the part itself, they are actually rather easy to simply break away. Afterward, EBM parts can be polished, coated, or machined using traditional techniques. This machine has pros and cons. For the pros, high density and therefore strength due to a full melt of the powder. Second, faster printing process. Third, non-sintered powder can be recycled. Fourth, fewer supports required compared to laser powder bed fusion. For the cons, First, small print volume, maximum 350mm diameter and 380mm height. Second, limited material selection, only titanium or chromium cobalt alloys. Fourth, expensive machine and materials. That's all from me. Thank you.